Okay, we're back for part 3 of our change of basis here. So we were concluding here at part 2, we tried to find the location in English of 5, 5. And so to do that, we need 3 of the first u1 vectors minus 2 of the u2 vectors. So therefore, the coordinates of 5, 5 from English to Italiano would be 3, negative 2 in Italian. Okay. Now, be careful when we're talking about going the other way around. So if I have 1, negative 2 in Italian, that means do 1 of the first vector and minus 2 of the second vector. So if we go 1 of the first vector minus 2 of the second vector, that would put us right here, which if you look on the IJ grid that I've put on here would be 3 units to the right and 1 unit down. So this would correspond to the point 3, negative 1 with respect to IJ. Okay, so let's go ahead and take a look at the similar situation over here, but with my first foreign language, which was Spanish. So if we take the point 5, 5, it's the same exact location from our origin. To get there using V1 and V2, notice that he's on a grid point here, and to get there, we would simply use 5 V1s with no V2s. So the coordinates of the English point 5, 5 would be the Spanish point 5, 0. Okay, and so you've got to pay attention what basis we're talking about here. As a little side analogy here, if I talk about log, if I just say log of x, okay, we understand that that just means log base 10 of x. If even though I don't write the 10 there, if I mean log base 2 of x, I actually have to write the 2 there. Okay, or if I mean log base e of x, which is sometimes called natural log of x, well, often it's called natural log of x. So we understand that this is the log base e, this is the log base 10, and if it's anything otherwise, then we denote it. So if we don't see any subscript here, we're going to agree with the convention that it's going to be with respect to the IJ basis. But if we do see a subscript here, it tells us that those are the coordinates with respect to some other not IJ basis. It's kind of like saying log base 2. So you have to make sure that you use these and pay attention to them when given. All right, so back here, what if I take a look at the point 1, negative 2, but with respect to the B prime basis? So if we do that, we're going to go 1 of the V1 vector minus 2 of the V2 vector, and that would put us right here. So this is 1, negative 2 with respect to the B prime basis. What would those coordinates be back in English? Well, starting at the origin, we go 1, 2, 3, 4, 5 to the right and down 1. So these would correspond to 5, negative 1 in the IJ basis. Okay, so be careful. We've got not just 2, but even 3 foreign languages going on here. Well, 3 languages. So what if we needed to convert from the Italian coordinate system, the red coordinate system, to the blue Spanish coordinate system? Well, as we've seen earlier, we need to take and use our basis vectors and make a transition matrix. So to get from the B basis to the B prime basis, we're going to have to take, we're going to have to take each of the B basis vectors, namely U1 and U2, and write them as a linear combination of the B prime basis vectors, V1 and V2. So we're going to take U1 and write him as some linear combination of V1 and V2. And U2 we'll write as some other linear combination of V1 and V2. Okay. Notice that we're taking and we're writing the U vectors as linear combinations of the V vectors. We're taking the B vectors and writing them as linear combinations of the B prime vectors. Now this is going to give me the same coefficient matrix where V1 was 1, 1, and V2 was -2, 1. So I'm going to augment by the U1 and the U2 so that I can actually solve both systems all at once. And U1 and U2 were the English vectors 1, 3, and -1, 2, because I have to communicate in some kind of language here. And so let's RREF that and find out who K1, 2, and M1 and M2 are. So on my calculator, when I put this in, I get RREF and I get the identity matrix here, as will always happen because we have a basis going to another basis. So I get 7/3, 1, 2/3, and 1. Okay, so I know who K1 and K2, M1 and M2 are, and we're going to use those to create a transition matrix Q. So we're going to let Q be these guys right here, 7/3, 2/3, and 1, 1. And this is going to transition us from the B basis vector coordinates to the B prime coordinates. Okay. So we're going to take the vector 5, 5, which was given in English. So before I can use my Italian to Spanish dictionary, I have to convert my English word into an Italian word. So for example, the word apple. In English, the word is apple. To convert that into Italian, I then have to know that that is mela. And then I'm going to use my Italian to Spanish dictionary to convert that to the Spanish word for apple, which is manzana. Okay, so let's go ahead and we need to write the 5, 5 vector in terms of the Italian coordinates. Oh, but wait, we did that on the bottom of the previous page. So 5, 5 with respect to the IJ coordinate system is equal to 3, -2 in the Italian coordinate system. And let's go ahead and multiply 7/3, 1, 2/3, 1 onto this 3, -2. Okay. Notice that this transition matrix takes us from B to B prime. And so if we multiply here, we'll get 7 plus -2, which is 5, and we'll get 2 plus -2, which is 0, which are the coordinates with respect to the B prime basis for that exact same location. That's pretty cool. And so how would we find the transition matrix that goes backwards from Spanish back to Italian? Well, I'm going to pause the video while you do that. Okay, we're back. So to do that, we take the B prime vectors and write them as linear combinations of the B vectors. That sets up this system, which we RREF. And then what's left over here becomes my transition matrix. So the P transition matrix that goes from B prime to B is 3/5, -3/5, -2/5, 7/5. And I have an extra question here. How is the P matrix related to Q? Well, I called the Q matrix C inside my calculator. Let's see if you can see that there. There we go. Now we got some light on the subject. And if I do the inverse of that C matrix, guess what I get? Okay, because that makes incredible sense. Because if Q goes from B to B prime basis, going backwards the opposite direction from B prime to B would be the inverse of the Q matrix, wouldn't it? Okay, so let's take our coordinates of the 5, 5 vector in, that we found above. Now remember, this is in English, so we got to turn the 5, 5 into Spanish coordinates. And the Spanish coordinates were 5, 0 with respect to the B prime basis. And so we're going to take this guy, 3/5, -3/5, -2/5, 7/5, and we're going to times by his b prime coordinates, which are 5 and 0, and let's see what we're going to get. So we're going to get 3 minus 0, which is 3, and we're going to get -2 plus 0, which is -2, which you'll notice are the coordinates of that same location, but with respect to the b basis coming from the b prime basis. And you'll recognize that up here. So here we did our transition matrix that took us from the b coordinate system to the b prime coordinate system. And since this was the same location, so if we go from the b prime coordinate system back to the b system, we should get the same result. Okay, let's stop there and then we'll finish up the bottom of this activity in our next video.